So in this video we're going to go over the idea of direction cosines. And the idea is that if we have a vector in three-dimensional space, we can measure the angle that this vector makes with respect to the positive x, the positive y, this is the x, the y, the z-axis. We can measure the angle that this vector makes with the positive x, positive y, and positive z-axis. And we're going to give that angle a name. We're going to say the angle that this vector makes with the positive x-axis is going to be alpha, and the angle that it makes with the positive y-axis is going to be beta, and then the angle that it makes with respect to the positive z-axis, we're going to call that gamma. And the idea is that we can use these three angles. We're going to let the cosine of those angles be the direction cosines. We're going to call them the direction cosines, and we'll see why it makes sense to call them the direction cosines in just a second. But what we want to do is back up a step and recall that we have identified a way to find the angle between two vectors. And we've also talked about the unit vectors in R3, I, j, and k. So remember, I was the vector 1, 0, 0, and that vector lies on and is parallel to the positive x-axis. The vector j was the vector 0, 1, 0 right here, which lies on and is parallel to the positive y-axis, and the vector k was the vector 0, 0, 1, which lies on and is parallel to the positive z-axis. So if we want to know the angle that a vector makes with the positive x, positive y, and positive z-axes, we just need to figure out the angle the vector makes with I, j, and k, because I, j, and k are parallel to the x, y, and z axes. So if alpha is the angle that I make with the positive x-axis, and I want to know what the cosine of alpha is, I use the fact here that I know how to find the cosine of an angle between two vectors. So if I find the angle between this vector, where this is an arbitrary vector v with components v sub 1, v sub 2, v sub 3, so just applying this idea that we've already developed, I can say, hey, the angle between this vector v and the positive x-axis is just going to be the angle that it makes with the angle between it and the vector I. And that's going to be v dot I divided by the size of v times the size of I. And the idea here is because I is a unit vector, it has length 1, the size of I is just 1, and that cancels. And then if we're dotting v sub 1, say v sub 2, v sub 3, with the vector 1, 0, 0, only v sub 1 is going to be preserved. So it turns out that the cosine of alpha, where alpha is this angle right here between the vector and the positive x-axis, is just v sub 1 over the size of v. And we wind up getting something similar for each of the other three. If I have beta as the angle between the vector v and the positive y-axis, to find that angle, I'm just going to find the angle this vector makes with the vector j right here. So I get v dot j over size of v times size of j, but the size of j is 1 because the vector j has length 1. And when I take the dot product with this vector, v dotted with the vector 0, 1, 0 is only going to preserve the second component. So we wind up with the size of v times 1 is the size of v, and we get v2 in the numerator. And similarly, when we take the vector gamma right here, we're going to wind up with v sub 3 over the size of v, dropping out of this angle calculation. So these are the direction cosines: the cosine of alpha, cosine of beta, cosine of gamma. And then what we want to do is revisit the idea of a unit vector. So we know that to make a unit vector in the direction of this vector v, unit vector is a vector of length 1, we called that vector v hat, and the way that we found v hat previously was we took v and we divided v by its own length, and we proved that this gave us a vector of length 1. So this right here is the unit vector, the vector of length 1 in the direction of v. And if we put it in component form, we're going to get v sub 1 over the size of v. When we distribute 1 over the size of v into the vector, v sub 2 over the size of v, and v sub 3 over the size of v. But notice from here, v sub 1 over the size of v is just the cosine of alpha. V sub 2 over the size of v is just the cosine of beta. And v sub 3 over the size of v is just the cosine of gamma. So it turns out that cosine alpha, the vector cosine alpha, cosine beta, cosine alpha gives us a unit vector in the direction of a given vector v, and that's why we call these the direction cosines, because they generate for us a unit vector in a specified direction, the direction of the vector v. And the other thing that we know from this is, because this vector is v over the size of v, or v hat, we know that this vector has length 1, and so if we calculate the length of this vector, the length of this vector is going to be just the cosine squared of alpha plus the cosine squared of beta plus the cosine squared of gamma. That's how you calculate the length of the vector. But if this vector has length 1, this distance or length calculation will be 1, and if you square both sides so that it cancels the square root out, you get that the sum of the squares of the direction cosine equals 1. So these are some handy properties. So it's very straightforward then to just to find the direction cosines. You're just doing this calculation. Cosine of alpha equals v sub 1 over size of v, cosine beta v sub 2 over size of v, cosine gamma v sub 3 over the size of v. So all we need to do to find the direction cosines is to determine the length of the vector, which is going to be the square root of the sum of the squares of the vector components, which is going to equal 1 plus 4 plus 9, which is going to equal the square root of 14. And this tells us that the cosine of alpha is going to be equal to v sub 1, which is 1, over the square root of 14. Cosine of beta, where beta is the angle that this vector makes with the positive y-axis, is just going to be the y component over the length of the vector. And the cosine of the angle that this vector makes with the positive z-axis we get from just finding the z component and dividing it by the length of the vector. So then if we needed to actually find the angles alpha, beta, gamma, we would need to take the arc cosine of both sides. So we would get that alpha is just the angle cosine inverse of 1 over the square root of 14. We would get that beta is just the cosine inverse of 2 over the square root of 14. And gamma would just be the cosine inverse of 3 over the square root of 14.